two codes are the International Building Code, or IBC, and the International Residential Code, or IRC, which are widely adopted in the United States for building construction. The IBC provides minimum requirements for the design and construction of commercial and multifamily buildings, including structural, fire safety, plumbing, and electrical systems. The IRC is specific to single-family homes and small multifamily dwellings, covering construction practices, energy efficiency, and safety measures. Most states have adopted the IBC and IRC as the basis for their building codes. Local jurisdictions such as cities or counties may have their own specific building code amendments and regulations that supplement the national codes. Building inspectors enforce the applicable codes during construction and inspection processes. How building codes are handled varies across different areas of the nation. Areas prone to earthquakes often have stricter building codes with specific requirements for seismic design. Some states in the Northeast and West Coast have adopted green building codes that emphasize energy conservation and sustainability. Coastal regions have building codes that address storm surges, wind loads, and flooding. Rural communities may have fewer local building code requirements compared to densely populated urban areas. Recent trends in building codes include digitalization, where building codes are increasingly being digitized for easier access and compliance. Environmental sustainability means green building codes are gaining popularity as awareness of climate change increases. Resilience means codes are being updated to enhance the resilience of buildings to natural disasters and climate impacts. Performance-based codes are being adopted by some jurisdictions that allow for flexibility in design while ensuring public safety. Adhering to building codes is crucial for ensuring the safety and habitability of buildings. Changes to building codes are ongoing, so it is important to consult with local authorities and building professionals for the latest requirements. Enforcement of building codes varies depending on the jurisdiction, so it is essential to understand local regulations and penalties. Consider electrical systems within the scope of these codes. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations. While not part of the IBC or IRC directly, the NEC is often referenced and enforced alongside them. It's essential to understand how these codes interrelate. Electrical requirements are integrated into building projects. The NEC covers various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. The IBC and IRC establish the framework for building construction, while the NEC provides the specific details for safe electrical practices. When designing and installing electrical systems, adherence to both building codes and the NEC is crucial to ensure compliance and safety. Here's a closer look at some key areas covered by the NEC that are relevant to building codes. Firstly, wiring methods. The NEC specifies acceptable wiring methods for different building types and occupancies. These include conduit systems, cable types such as non-metallic sheath cable or NN cable, and armored cable or AC cable, and other wiring techniques. Secondly, overcurrent protection, which focuses on circuit breakers and fuses. The NEC mandates the use of overcurrent protection devices to protect electrical circuits from overload and short circuits. The code provides guidelines for selecting the appropriate size and type of overcurrent protection for various applications. Thirdly, grounding and bonding. The NEC requires proper grounding and bonding of electrical systems to minimize the risk of electrical shock and fire hazards. The code specifies methods for grounding electrodes, equipment grounding conductors, and bonding of metallic components. Fourthly, equipment installation, which entails lighting fixtures, receptacles, and electrical panels. The NEC provides detailed requirements for the installation of electrical equipment, including lighting fixtures, receptacles, switches, and electrical panels. These requirements ensure safe and reliable operation of electrical systems. It's important to be aware of the specific electrical requirements in your local jurisdiction, as amendments or variations to the NEC may exist. Consult with qualified electrical professionals and building inspectors to ensure compliance with all applicable codes and regulations. Understanding the role of local amendments in building codes is critical for ensuring compliance. Local jurisdictions often modify national codes like the IBC, IRC, and NEC to address specific regional needs or concerns. These amendments can vary significantly from one location to another, affecting everything from structural requirements to energy efficiency standards. To navigate this complex landscape effectively, firstly, identify the relevant local jurisdiction. Determine the specific city, county, or municipality responsible for enforcing building codes in your project area. Secondly, research local code amendments. Obtain copies of any local amendments to the national codes that are in effect. These amendments are typically available from the local building department or online resources. Thirdly, understand the differences. Carefully compare the local amendments to the base national codes to identify any differences or additional requirements. Pay close attention to areas such as seismic design, wind load resistance, energy conservation, and accessibility. Fourthly, consult with local experts. Engage with local building officials, architects, engineers, and contractors who are familiar with the specific code requirements in your area. Their expertise can help you navigate complex issues and ensure compliance. Fifthly, maintain accurate documentation. Keep detailed records of all applicable codes, amendments, and interpretations. This documentation will be essential for obtaining permits, undergoing inspections, and demonstrating compliance. Sixthly, stay up to date. Building codes and amendments are subject to change, so it's important to stay informed about the latest updates in your local jurisdiction. Subscribe to industry newsletters, attend training seminars, and regularly check with the local building department for any revisions. Seventhly, seek clarification when needed. If you encounter any ambiguities or uncertainties in the code requirements, don't hesitate to seek clarification from the local building officials or qualified professionals. Obtaining written interpretations or rulings can help prevent costly errors or delays. By understanding and adhering to local code amendments, you can minimize risks, avoid costly rework, and ensure the safety and durability of your construction projects. Consider the importance of proper permitting and inspection processes in building projects. Obtaining the necessary permits and undergoing inspections are critical steps in ensuring compliance with building codes and regulations. These processes help verify that construction work meets minimum safety standards and protects the health and welfare of occupants. To navigate the permitting and inspection processes effectively, firstly, determine permit requirements. Identify the specific permits required for your project based on its scope, location, and type of construction. Common permits include building permits, electrical permits, plumbing permits, and mechanical permits. Secondly, submit permit applications. Prepare and submit complete and accurate permit applications to the local building department. Include all required documentation such as architectural plans, engineering drawings, site plans, and energy calculations. Thirdly, pay permit fees. Pay the required permit fees as determined by the local jurisdiction. Permit fees typically vary based on the project's valuation, size, and complexity. Fourthly, schedule inspections. Coordinate with the building department to schedule inspections of various stages of construction. Common inspections include foundation inspections, framing inspections, electrical inspections, plumbing inspections, and final inspections. Fifthly, prepare for inspections. Ensure that the construction site is safe and accessible for inspectors. Have all necessary documentation available, such as approved plans, permits, and material specifications. Sixthly, address deficiencies promptly. If the inspector identifies any deficiencies or violations during an inspection, address them promptly and schedule a re-inspection to verify compliance. Seventhly, obtain certificate of occupancy. Once all inspections have been successfully completed and the project meets all code requirements, obtain a certificate of occupancy or CO from the building department. The CO is required before the building can be legally occupied. Eighthly, maintain records. Keep copies of all permits, inspection reports, and the certificate of occupancy for future reference. These documents may be required for property transactions, insurance claims, or future renovations. By following the permitting and inspection processes diligently, you can ensure that your building project complies with all applicable codes and regulations, protecting the safety and well-being of occupants and the public. Let's delve into the significance of continuing education and professional development for building professionals. The building industry is constantly evolving, with new technologies, materials, and code requirements emerging regularly. Continuing education and professional development are essential for building professionals to stay current, enhance their skills, and maintain their competency. Benefits of continuing education and professional development are firstly, keeping up with code changes. Building codes are updated periodically to reflect advancements in technology, safety standards, and sustainability practices. Continuing education helps building professionals stay informed about the latest code changes and their implications for design and construction. Secondly, learning about new technologies and materials. The building industry is characterized by continuous innovation, with new technologies and materials being introduced regularly. Continuing education provides opportunities for building professionals to learn about these advancements and their potential applications in building projects. Thirdly, improving skills and knowledge. Continuing education and professional development enhance the skills and knowledge of building professionals in areas such as design, construction, project management, and code compliance. This leads to improved performance, efficiency, and quality of work. Fourthly, maintaining licensure and certification. Many building professions such as architects, engineers, and contractors require continuing education to maintain their licenses or certifications. Continuing education ensures that professionals meet the ongoing competency requirements established by regulatory agencies. Fifthly, enhancing career prospects. Continuing education and professional development can enhance career prospects for building professionals by demonstrating their commitment to lifelong learning and professional growth. This can lead to increased job opportunities, higher salaries, and career advancement. Sixthly, promoting professionalism and ethics. Continuing education reinforces professionalism and ethical conduct among building professionals by providing training in areas such as ethics, risk management, and client relations. This helps build trust and confidence in the building industry. Options for continuing education and professional development are firstly, attending conferences and seminars. Industry conferences and seminars offer opportunities for building professionals to learn from experts, network with peers, and explore the latest trends and innovations. Secondly, taking online courses and webinars. Online courses and webinars provide convenient and flexible learning options for building professionals to enhance their knowledge and skills from anywhere with an internet connection. Thirdly, participating in workshops and training programs. Workshops and training programs offer hands-on learning experiences for building professionals to develop practical skills in areas such as construction techniques, software applications, and code compliance. Fourthly, pursuing certifications and credentials. Obtaining professional certifications and credentials demonstrates expertise and competency in specific areas of the building industry. Certifications are available for various specialties, such as green building, energy efficiency, and project management. Fifthly, reading industry publications and journals. Staying informed about the latest developments in the building industry through industry publications and journals is an essential form of continuing education. These resources provide valuable insights, case studies, and best practices. By investing in continuing education and professional development, building professionals can enhance their skills, knowledge, and career prospects while contributing to the advancement of the building industry and the safety and sustainability of built environments. Discuss the role of green building practices and sustainability in modern building codes. Green building practices and sustainability are increasingly integrated into modern building codes, reflecting a growing emphasis on environmental responsibility and resource conservation. Green building practices aim to minimize the environmental impact of buildings throughout their life cycle, from design and construction to operation and demolition. Sustainability focuses on meeting the needs of the present without compromising the ability of future generations to meet their own needs. Integration of green building practices into modern building codes has several key objectives. Firstly, energy efficiency. Green building codes promote energy efficiency through measures such as improved insulation, high-performance windows, efficient HVAC systems, and renewable energy sources. Reducing energy consumption lowers operating costs and reduces greenhouse gas emissions. Secondly, water conservation. Green building codes encourage water conservation through measures such as low-flow fixtures, rainwater harvesting systems, and efficient irrigation practices. Conserving water resources reduces strain on water supplies and lowers water bills. Thirdly, material selection. Green building codes promote the use of sustainable materials that are renewable, recycled, or locally sourced. Using sustainable materials reduces environmental impacts associated with extraction, manufacturing, and transportation. Fourthly, indoor environmental quality. Green building codes address indoor environmental quality by promoting measures such as natural ventilation, low VOC materials, and daylighting. Improving indoor air quality and lighting enhances occupant health and well-being. Fifthly, waste reduction. Green building codes encourage waste reduction through measures such as construction waste management plans, recycling programs, and deconstruction practices. Reducing waste minimizes landfill disposal and conserves resources. Examples of green building codes and standards are the International Green Construction Code, or IGCC. The IGCC is a model code that provides minimum requirements for green building design and construction. It covers a wide range of sustainability topics, including energy efficiency, water conservation, material selection, and indoor environmental quality. The Leadership in Energy and Environmental Design, or LEED, rating system. LEED is a widely recognized green building certification program that evaluates buildings based on their environmental performance. LEED certification is often required or incentivized by local jurisdictions for new construction and renovation projects. The National Green Building Standard, or NGBS. The NGBS is a consensus-based standard that provides criteria for green building practices in residential construction. It covers a range of sustainability topics, including site design, energy efficiency, water conservation, and material selection. Local green building programs. Many local jurisdictions have developed their own green building programs and incentives to promote sustainable construction practices. These programs may include tax credits, density bonuses, and expedited permitting for green building projects. The integration of green building practices and sustainability into modern building codes is driving innovation in the building industry and leading to more environmentally responsible and resource-efficient buildings. As awareness of climate change and environmental issues continues to grow, green building practices are likely to become even more prevalent in the future. Examine the impact of technology on building code compliance and enforcement. Technology is revolutionizing building code compliance and enforcement, making the processes more efficient, accurate, and transparent. Digital tools and platforms are streamlining various aspects of code compliance, from plan review and inspections to data collection and reporting. Impact of technology on building code compliance and enforcement is firstly building information modeling, or BIM. BIM is a digital representation of a building that integrates all aspects of its design, construction, and operation. BIM enables building professionals to visualize and analyze building designs in 3D, identify potential code compliance issues early in the design process, and coordinate construction activities more effectively. Secondly, electronic plan review, or e-plan review. E-plan review systems allow building departments to review and approve construction plans electronically, eliminating the need for paper-based submissions. E-plan review streamlines the plan review process, reduces turnaround times, and improves communication between building officials and design professionals. Thirdly, mobile inspection apps. Mobile inspection apps enable building inspectors to conduct inspections in the field using smartphones or tablets. Inspectors can access building plans, code requirements, and inspection checklists on their mobile devices, allowing them to perform inspections more efficiently and accurately. Fourthly, data analytics and reporting. Data analytics tools enable building departments to collect and analyze data on code compliance, inspection outcomes, and building performance. This data can be used to identify trends, track progress, and improve code enforcement strategies. Fifthly, virtual reality, or VR, and augmented reality, or AR. Virtual reality and augmented reality technologies are being used to train building inspectors, visualize building designs, and conduct remote inspections. VR and AR provide immersive and interactive experiences that enhance understanding and communication. Challenges and considerations of technology adoption are firstly, interoperability. Ensuring that different technology systems can communicate and exchange data seamlessly is a key challenge in technology adoption. Building departments need to establish standards and protocols for data exchange to promote interoperability. Secondly, cybersecurity. Protecting building data from cyber threats is a critical concern for building departments. Implementing robust cybersecurity measures is essential to safeguard sensitive information and prevent unauthorized access. Thirdly, training and support. Providing adequate training and support to building officials and industry professionals is essential for successful technology adoption. Building departments need to invest in training programs and technical assistance to ensure that users are proficient in using the new technologies. Fourthly, cost. Implementing new technology systems can be costly, especially for smaller building departments. Building departments need to carefully evaluate the costs and benefits of technology adoption and prioritize investments that will provide the greatest return. Despite these challenges, the benefits of technology in building code compliance and enforcement are significant. By embracing digital tools and platforms, building departments can improve efficiency, accuracy, and transparency, ultimately leading to safer and more sustainable built environments.